Hello everyone. In this video, we're going to control the servo motor using potentiometer, and we're going to print the value of the rotational range on our OLED screen. And so in this project, we're going to use the timer and ADC, and finally I2C communication feature on our MCU board. So, well, if you want to follow this tutorial, just configure the circuit as you can see. Before we jump into the configuration part, well, I'm gonna explain how I map an ADC value to an SG90 servo motor. And so if you take a look at this datasheet over here, this is the datasheet of the SG90. And so the rotational range is 180 and the pulse cycle is around 20 milliseconds. And the pulse width, as you can see, is 0.5 millisecond to 2.4 millisecond. But the typical value is 2.5 millisecond, not 2.4. So we're going to use the typical value instead. And first things first, the clock source we're going to use is HSI clock, which is 8 megahertz. And I'm going to use timer 2. Well, a servo needs a 20 millisecond period, which means 50 hertz PWM. And if we set the prescaler of our timer to 15, then the timer clock becomes 500 kilohertz. That gives us 2 microseconds per count over here. And with an ARR value of 9,999, the total period is 20 milliseconds, as you can see. Now for the pulse width, well, 0.5 milliseconds stands for 0 degrees, and 1.5 milliseconds stands for 90 degrees. And finally, 2.5 milliseconds would be 180 degrees. So converting this to timer counts, well, 0.5 milliseconds is divided by 2 microseconds. The value of the counter would be 250 counts. And if we divide 2.5 milliseconds by 2 microseconds, then it will be 1,250 counts. And so the valid PWM value would be 250 to 1,250, as you can see. Well, the ADC value would be 0 to 4,095. And I scale it by dividing by around 4.1, which gives 0 to 1,000. Then I add an offset of 250. And so, well, this value directly maps the ADC input to the servo angle from 0 to 180 degrees. So this is all about the entire explanation of how I map an ADC value to an SG90 servo motor. Now let's move on to the configuration part. First things first, the clock configuration. Well, if you take a look at this datasheet over here, timer 2 is connected to the APV1. So in this case, the APV1 timer clocks is 8 megahertz now. So, well, this is the default setting of the STM32Cube IDE, so I'm not going to set anything, the extra settings. Let's move on to the pin out configuration. First things first, we're going to use the serial wire, and I'm going to set up the I2C1 communication feature. I'm going to use the fast mode. And well, after that, I'm going to move on to timer 2, and the clock source would be internal clock, and I'm gonna use the channel 2 and I'm gonna generate the PWM. So click PWM generation channel 2. And when it comes to prescaler, like I said, I'm going to set 15 in this case. And when it comes to the max value of the counter, it will be 9,999. There we go. And finally, I'm gonna set up the ADC. Well, I'm going to use the uh, ninth input. And when it comes to continuous conversion mode, I'm gonna enable this setting. And this is all about the pinout configuration. So I'm gonna generate the code right away. Well, the code is generated as you can see, and as you probably can tell, this project uses an external file for OLED control. So I've already included this file and this file over here. So in this video, I'll focus on the application side. Well, to save the time, I throw in some code over here and over here and over here and this one. And from line 91 to well, line 124. So you just type in this kind of code if you're following this tutorial. Now let's move on to the coding part. So we're going to start the feature of ADC and timer and OLED. And so in this case, we have to throw in the handler. So there is the pre-defined handler over here. So I'm gonna throw in this variable over here. There we go. And after that, the timer. I'm gonna throw in this timer to start this feature. And after that, well, since we're using the timer 2, we have to throw in the timer channel 2 over here. Copy and paste it. And then we move on to the while loop over here. So to start the ADC conversion, we have to throw in the ADC handler again over here. And well, this function, this parameter is timeout. So I'm going to throw in 1000, which is 1 second. And after that, when the conversion is done, we have to read the ADC value. So I'm going to throw in this parameter again. Well, when it comes to this calculation related code, I've already explained about this entire procedure, how I get the value of PWM. So in this case, I have to figure out the degree value. So I'm gonna divide this value by 4095 and I'm gonna multiply 180 degrees to get the degree value. And after that, as you already can tell, well, I'm gonna divide by 4.1 and I'm gonna throw in the offset, which is 250. Yeah, and then, well, because of the max value, the max value of degree is around 177, I have to implement the clamping. Well, if the degree of the value of the degree is above 175, I'm gonna consider this value as 180. And after that, I'm going to generate the PWM for servo motor. So if you take a look at this function, the first parameter would be handler, and the second one will be channel, and the last one would be the value of PWM. And so the handler would be this one. Well, there you go. And then the channel. And we already calculate the PWM. So I'm going to throw in this value directly. There we go. Well, after that, I'm gonna display the value of the degree on the OLED screen, and this is the entire chunk of that code. And I've already tested before, and I found that the OLED screen is blinking too frequently, so I'm gonna compare the value of the degree between the previous one and the current one. So that's why I throw in this value, the previous degree value over here to compare. So if the current degree is different from previous degree, then only when this result of this operation is true, I'm gonna update the screen. So I'm gonna update the value here. There we go. And then I'm gonna delay this for a while, just in case. And I'm gonna build this project. So build is completed. Well, I just unloaded the code right now. So when I turn the potentiometer dial, the servo motor rotates between 0 and 180 degrees. And you can see the OLED screen updating at the same time. You can also confirm that when the ADC value doesn't change, there is no flickering on the OLED display. It looks like everything is working properly. Well, this is all about today's tutorial, and I hope you find it very useful through this video. Well, thanks for watching, and see you on my next video. Bye guys.